So today we're going to cover Chapter 1, Section 4. Today we're going to talk about finding perimeter and area of polygons. Today it'll be just triangles, but what we're going to be doing is graphing points on a coordinate plane and then connecting those points to turn it into a triangle. Also in this lesson, we're going to learn how to classify polygons based on their number of sides. So let's look and see what the definition of a polygon is. So a polygon means many angles. So if you think about the word polygon, and if you think about vocabulary, the prefix here, poly, means many. So gon is going to represent angles. So the word polygon means many angles. Now, in order for a polygon or a shape to be a polygon, these three things need to happen. So a polygon is a closed plane figure. It can't have a hole in it. It can't be open, formed by coplanar segments called sides. So the segments or the sides are created from segments. Each side must intersect exactly two sides, one at each endpoint. So for example, if I have a segment, then each one of these has to intersect another side at each of the endpoints. So that could be an example of a closed figure, and it's the smallest polygon you could create, which is a triangle. Now it also says no two sides with a common endpoint are collinear. So for example, I can't have a side of my polygon where it goes from here to here and it's collinear. I couldn't put another point here and I couldn't say that this is a polygon because I can't have two separate sides on the same line. That's what this number 2 says. Each endpoint of a side is a vertex of the polygon. So all of these endpoints are going to be, and this one, it's not there. So over here, these are all called vertices. So let's go ahead and let's see if we can identify which pictures are polygons on the next slide. So for part A satisfies all three conditions. It's a closed figure. We don't have more than 2 points. So we don't have like a bunch of points on the same line trying to say that these are sides. Each one hits at an endpoint. So this one, yes, it's a polygon. However, part B, we got a hole here. It's not closed. So this one's not a polygon. Example C is showing that number 2 on the previous slide. See, I have a point here, point here, point here. This can't exist. I can't have 3 different segments here on the same line. So this one's not a polygon. This one is. It satisfies all 3 conditions. And the last one is not. Number 1, it's not a closed figure. So that makes it not a polygon. Also realize that the sides are not intersecting both endpoints. You don't have anything closed here or touching these endpoints. To be able to identify when I give you a shape if it's a polygon or not. Also, another characteristic of a polygon is it can't have any curved sides. Remember, by definition, it's a closed plane figure and it's formed by segments. So no curves, no arcs, no rounded edges. Okay, next we're going to talk about whether a polygon is concave or convex. First, we're going to talk about what it means to be convex. Be the next slide. So like the star here, if I were to draw a line on this side, see how it hits the inside here? So before it was like shaded in yellow. As soon as you draw this line, it goes into the yellow part, so this would be concave. And that's what we're going to learn on the next slide. So convex polygon can be, you can determine if it's convex, where no line that contains a side of the polygon contains a point in the interior of the polygon. So if you look at the middle one, where it's got the red lines on the outside and then the interior is shaded in yellow, what they've done is they've taken these red lines and drawn them along the sides of the polygon. Notice when I draw that red line, the red line does not go into the interior. So this classifies this as a convex because when I draw all of these lines on top of the sides, the red line never enters the interior. This makes this convex. This last one over here, this hexagon, is also convex because again, when I draw lines on top of the sides, it doesn't go into the interior. So these are all examples of convex polygons.
So that star from before, that was not convex, right?
Correct, that's concave. Good. So again, as you draw your line on top of the sides, if that line goes into the interior, it's going to be classified as concave. So on this one, if I were to draw a red line on top of this side, remember a line goes forever, notice the red line now ends up in this interior portion of the polygon. So this would be an example of a concave polygon. Now, another way that I always think about it is I look at it and I think, oh, this side looks like it's caving in, so it's concave. Whereas the convex are all going to point outward. Now, you don't need to check all of the sides to see if they go in. Soon as you find one side that when you draw a line on top of it, it goes to the interior, then that automatically makes the polygon concave. So again, think of the side as like caving in. Everybody good on concave and convex? All right. Now we're going to classify polygons. So what you'll do is you're going to count however many sides are in the picture, and then you're going to have to give the name of the polygon. So the smallest type of polygon you can create is a triangle, and it's a three-sided figure. A four-sided figure is called a quadrilateral. Now you've probably seen specific quadrilaterals like squares and rectangles and rhombuses, but just remember that in general, a four-sided figure is called a quadrilateral. A five-sided figure is a pentagon. There's actually a building in Washington that is 5 sides and it's a pentagon. Then there's the six-sided figure and it's called a hexagon. Now to help me remember, because I got 2 H words here, to help me remember which one is the 6, I know that the word 6, when I spell it, has an X, and so does the word hexagon. So that helps me to remember that the 6-sided figure is a hexagon. 7-side is a heptagon. 8-side is an octagon. I remember that because I think of an octopus. It has 8 arms. For nonagon, if you spell the word 9, notice it's got like an N and an N, and so does the word nonagon. You just switched up the vowel that was there. 9 has an I, nonagon has an O. Decagon is a 10-sided figure. You can also think of a decade, which is 10 years. Dodecagon is the 12-sided figure. Notice they jump over 11. 11 doesn't have a special name. When we refer to 11-sided figure in this class, we're just going to call it 11/GON. And that's what they're saying here. So all you do is N is the number of sides, and then you're just going to put a dash and then write the letters GON. If it were a 100-sided figure, you would call it 100 and then a dash and then GON. So be able to recognize the names and however many sides it's associated with. The next slide, we're going to determine, is the picture a polygon? And if it is, we're going to decide, is it concave or is it convex? So for the next one, for part A, this one is not a polygon. Now, if the figure looked like this one's not, but this one, yes, it is a polygon. And again, if you were to draw one of the sides and make a line on top, this would be a concave polygon. B, this is a closed figure. We don't have more than 2 endpoints on that's collinear. So yes, this is a polygon. And notice if I draw my lines here, I haven't found one yet that goes into the interior. So this one would be convex. The next one, I know it's kind of hard to see, but this side right here has a curve to it. It's not a segment. So because this is curved, or you could also say it's an arc, you would say this is not a polygon. We can't have any curved sides.
I have a question.
Yes.
So to tell whether it's not a polygon, it can't be curved, or what are the other two that you said it couldn't be?
Okay, so it can't be open, it has to be closed. And you can't have something like that star type picture. Like you can't have 2 points here and then say that this is a side, this is a side, here and here. You can't have a side that looks like this. They can't be collinear, the endpoints.
Thank you.
Then the last one. Notice it's a closed figure. None of my points, endpoints are collinear. So we would say, yes, this is a polygon. And as soon as I try to draw a line across one of the sides, notice it goes into the interior. So this would be concave. So it looks like these sides are caving in.
Miss Corey,
Yes.
for C, is it like concave or convex, or can that not be classified?
So whenever you say it's not a polygon, you're not going to classify it. So because it had the curved side, we're not classifying here. Same thing on this one. Since this one was not a polygon, it didn't get a classification. But as soon as I took out this line and turned it into this picture, then I could classify it. Okay, next we're going to still classify convex or concave on the next slide, but we're also going to give the polygon name based on its number of sides. So for the first one, we're going to count how many sides. 1, 2, 3, 4, 5, 6. A 6-sided figure is called a hexagon. And if I were to draw lines along the sides, notice none of these lines go into the interior, so making this convex. Going to count the number of sides for B. It's got 1, 2, 3, 4. The general name for this 4-sided figure is a quadrilateral. And again, if I were to draw lines, none of them enter into the interior, so this one is also convex. Specifically, this is a picture of a parallelogram, but we haven't gotten there yet. Just know it's a quadrilateral. And then the last one, it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Our 12-sided figure is a dodecagon. And again, if I draw a line along one of the sides, boom, it goes inside, making this concave. Pretty good. Okay, now we're going to talk about perimeter and area. And you probably have done this, probably maybe in 5th grade, maybe in middle school. So whenever you find the perimeter of any polygon, all you're doing is finding how long each of the sides are and then adding them up. Now, probably in middle school, they probably gave you a picture, and let's say they told you this was 3, 4, 5, and they said find the perimeter, then you would know that you would just add 3 plus 4 plus 5. What's different about this lesson is I'm not going to give you a picture like this with the sides labeled. I'm going to give you ordered pairs. You're going to graph them on a coordinate plane, connect the points, and make your shape. Now, when the sides are vertical or horizontal, we can just count the squares. But when the side is a diagonal segment, we're going to need to do the distance formula. So here are the formulas. So for the perimeter of a triangle, again, you just add up all of the outside sides. Remember, for area of a triangle, we're always looking for the height, and it's always indicated with a right angle. So that formula is 1/2 base times height. You might have also memorized it as base times height divided by 2. So either one. Perimeter of a square. We know when we have a square, all 4 sides are equal. So to find the perimeter, if this side length was 3, I could just say 4 times 3, or I could also do 3 plus 3 plus 3 plus 3, because I know all sides are the same. When I do area, if it's a square, I could just square that side. Now, you could also do base times height or length times width. Just remember that when it's a square, the base and the height are going to be the same number. So a rectangle, you probably learned it in elementary school as length times width, and then in middle school they probably again talked about base times height. For perimeter, remember opposite sides in your rectangle are equal, so notice you have 2 L's, which is here, and then you have 2 W's, which is here. You can times it by 2 and then add them, or you could also do W plus L plus L, and that would give you the perimeter of the rectangle. When we write our answers for perimeter, it's always going to be linear units. So just whatever the units are, no square, no cube. So linear units are written for perimeter. And when I'm talking about linear units, I'm talking about units that are like inches, feet, meters. These are all examples of measuring something in length, linear. For area units, these are going to be square units. And again, they're still going to be linear. So like we could say square feet. You might also see it written like this. Could also be square meters, or m to the second power. Could be inches, could be yards, any kind of linear unit. So area, the units are always squared. Perimeter are just the units that are given to you. So we're going to do 2 examples here of finding perimeter and area. So the first one is asking us to find the perimeter of triangle ABC. So see this little symbol? Instead of writing the word triangle, they draw a picture of it, and then you can put the 3 vertices. So I'm going to graph A, -2, +3. I'm going to graph B, +3, -3. And then I'm going to graph C, -2, -3. Now what I need to do is connect my vertices. And now I have to figure out how long the black side is, the blue, and the green. Now for the black side, it's the distance between A and C. So A is 2, -2, 3. C is -2, -3. You can either cross off the numbers that are the same, and now we'll just subtract. And I get 6, or count the squares. 1, 2, 3, 4, 5, 6. This side length is 6. I'm going to do the same thing for BC. Again, cross off the number that's the same, and you could just subtract or count the squares. 1, 2, 3, 4, 5. So 6 and a 5. Now I have to find the distance of the blue one. I need to use the distance formula. x2 minus x1 squared plus y2 minus y1 squared, all under the radical. And I'm going to use this to find the length of AB. So point A, -2, 3, and B is going to be +3, -3. So now what I need to do is subtract. So this will be x2, y2, x1, y1. So let's plug it in. 3 minus -2 squared plus -3 minus 3 squared, all under the radical. 5 squared plus -6 squared, all under the radical. 25 plus 36, square root of 61. Now, if we were leaving this in simplest radical form, we would leave it like this. However, if I get out my trusty calculator, I could approximate this to about 7.8. The question asks for perimeter, so what I need to do is go back. I'm going to add the 5, the 6, and the 7.8 that I just got, and it would be 18.8 units. Now, if the instruction said to leave it in simplest radical form, I would add 5 plus 6 plus the square root of 61. These two I would add together and then just leave the square root of 61. So either answer, depending on how they ask you to leave it. One more quick example. It's an area question. I'm going to quickly graph those 3 order pairs. So D is at 1, 3. E is at 4, -3. And F is at -4, -3. I'm going to connect these and make my triangle. It wants area this time. So area formula is 1/2 base times height. My base is right here. It's the distance or the length of EF. I can count the squares. 1, 2, 3, 4, 5, 6, 7, 8. Has a length of 8. So B equals 8. I could also take EF, and I could take those two order pairs, find the two numbers that are the same, and now subtract. 4 minus -4, and I get 8. Now, to find the height, I'm going to draw in the line that goes straight down, and for this one, I'm just going to count the squares. 1, 2, 3, 4, 5, 6. It has a height of 6. So now I plug the B and the H into the formula. So area equals 1/2, 8 times 6. Area equals 24, and I don't have any inches or feet, so I'm going to say these are units squared, or I could write out the word squared units, or square units, no D, square units. So that would be how you would do an area question by being given order pairs, and then you would graph them. Now, you could also do the area base times height divide by 2, 8 times 6 divide by 2. I like to do it this way, and then I just take one of my numbers, either the base or the height, divide it by 2, and then multiply what remains. You can do it either way. So that is it for the notes for today.
Can you go to the perimeter one again?